is a 30, 60, 90. We actually already dealt with a 30, 60, 90, okay? We already determined that if this is a 30, 60, 90, and the hypotenuse of the triangle, which is also the radius of the circle, is 1, this is really the same triangle as the orange triangle, just turned a different way. And the side length must be 1/2 and root 3 over 2. What's going to be the difference here then at 60 degrees between 30 degrees? Eric? Flipped. Okay, so he's saying, good, the x and the y coordinates are switching. So, here's the good news. Even though 30 degrees is not as nice as 45, and you don't get the same two numbers for your x and y coordinates, the same two numbers that you use to develop your 30-degree ordered pair are the same two numbers in 60 degrees. So I personally have memorized that for every 30 or 60, the numbers that are going to pop up are going to be either 1/2 or root 3 over 2. But again, you guys know I struggle with strict memorization. So what I like to do is then reason it out. I always think to myself, is this a 60 or a 30? And I know for the 30s, the long part was the x and the short part was the y, which is why the rad 3 over 2 is the x coordinate and the 1/2 was the y coordinate. Where at a 60-degree location, the shorter distance is the x distance, the longer distance is the y distance, which means 1/2 is going to be the x coordinate, and root 3 over 2 is going to be the y coordinate. Is this okay with everybody? Okay. All right, and so then in the second quadrant, we know that the coordinates are going to stay the same, but with a negative x coordinate and a positive y coordinate. In the third quadrant, the same coordinates, but they're both going to be negative. And in the fourth quadrant, a positive x coordinate and a negative y coordinate. Okay? So then, what's going to be the sine of 60 degrees? Rad 3 over 2. Because sine is like the y coordinate. The y coordinate at that position is rad 3 over 2. Now, we did everything with a unit circle, but I remind you guys, if we had made the circle bigger, all that would have happened is, so the radius would have been bigger, which meant the side lengths would have been bigger. But then when you did the sine, like the y over the r, this stuff would have canceled out, and you still would have ended up with root 3 over 2. Okay, that's why we used 1 as the radius, to avoid having to cancel stuff out every single time. So it doesn't really matter if it's a bigger circle or smaller circle. The sine, cosine, tangent ratios, that stuff cancels out that makes the circle bigger or smaller, and we still end up with the same ratios. So we're allowed to use the unit circle, and that means that we can say for any 60-degree angle, like if someone just asks us, what is the sine of 60 degrees, we know it's going to be root 3 over 2. Okay? Is this all right with everybody? All right, so your job is to know the unit circle, the whole thing, all of this information. And so if I had just handed you all of this information and said memorize it, that's a lot of information and it's overwhelming. But hopefully the way we did it, you guys saw some distinct patterns, and you now have some distinct connections and ways that you could figure it out even if you didn't remember it. So I know that like things that are associated on the axis all have points made up of 0 and 1. Okay? Positive, negative, depends on location, right? Anything that has a reference angle of 45, what's the number I'm going to stick with 45? Rad 2 over 2. Okay? Anything that's a 30 or 60, what numbers are going to come with those? Rad 3 over 2 or 1/2. Which one's which? Either you're going to be a really good memorizer and know that in 30 degrees it's always a root 3 over 2x and a 1/2 y. Or if you're like me and like I always get them mixed up, I can always just think about which part is longer and which part is shorter in the 30 compared to the 60, and I can rationalize which one belongs in the x and which one belongs in the y. Is that okay? All right, now how do we find the tangent of any of the angles? So to find the tangent of an angle, what do you do? Y over x. So knowing just knowing the ordered pair, I can still answer anybody's question about tangent. Maybe not as quickly because I have to actually go and divide. So you have a choice to make. You guys can either look for some patterns in the tangents as well. Okay? And I'll be honest, I know what numbers pop up in the tangents. I don't always know which one is which. But if I just think about the setup of the division problem, then I automatically know which one it is because I'm familiar with the answers and I'm familiar with the setup, and then that helps me figure it out. So what we're going to do is make a little list for ourselves. Now, you guys can do this on the back of your plate if there's space, or you can do it in your note guide. So your note guide has just a very couple of things in this section because clearly our plate kind of gave us all the information that we needed. But I want to talk about tangent values and reciprocal functions for a little bit, because, I don't know, up here it might be confusing. So, for example, what's the sine of 30 degrees before we write anything down? So the sine of 30 degrees is 1/2. What is the cosecant of 30 degrees? 2. Okay? So I didn't teach you any of those technically, but if you know how they're related to sine, cosine, and tangent, and you know your unit circle, then you should be able to figure out those values as well. Okay? All right, so for tangents, what I'm going to do is I'm going to make a list of tangents I want you guys to go calculate right now. And then you guys can look at what the results are possibly going to be each time that you do something like this. All right, so let's do the tangent at 90 and the tangent at 180. So we can look at some points along the axis. Okay, so I'm deliberately picking like a piece of each. This is nowhere. You can either put it in some space on your note guide or you can put it on your plate. It's totally up to you. Like on the back of it. Let's look at the tangent of 45, the tangent of 30, and the tangent of 60. Okay? So your goal right now is just going to be to go through and calculate these tangents. We've talked about the tangents of the 90 and 180 previously. We've talked about the tangent of 45 previously. We didn't really talk about the tangents of 30s and 60s much, but I want you to figure them out. Now, I didn't ask you another 30-degree reference angle because you're going to be doing the same thing every time if it's one of the 30-degree angles, but negatives and positives will change. So we just need to look at like the number stuff that's going on right now. And I want exact values, so if there's like radicals, I want the radical in the answer. Okay? So take a minute. So calculations involving the 0 and 1 points. So things like 90, 180, 0, 360, 270, all those points along the axis. You're either going to get some value of 1 over 0 or some 0 over some value of 1. So they're either going to work out to be, if 0 is in the denominator, undefined. If 0 is in the numerator, 0. Okay? So you can either memorize at which points the tangent would be undefined. So the tangent would be undefined at 90 and where else? 270. And it would be equal to 0 at 180 as well as at 0 or 360. Okay? So you have a choice. You can memorize that, or, I don't know. I know that all of the axis points are either 0 or 180, 0 or undefined, but I'm always doing this little thought process in my head like, oh, does the 0 end up on the bottom or not? Okay? So the only reason I'm telling you guys that is if you're really good at memorizing and you want to memorize it all, awesome. But if you're not and you're like, this is an overwhelming amount of information, if you understand how it works well, you can still get there without having everything be like robot, like, oh, you enter it and I say it, like a calculator. I can like think for a second and figure it out and it's okay. All right? All right, so tangent at 45. We discussed this a little bit last time. Root 2 over 2 divided by root 2 over 2, 1. So every angle that has a 45-degree reference angle, the tangent is either going to work out to be 1 or what? It has a 45-degree reference angle, so at all those marks, 45 around your circle, it's either going to be 1 or -1, depending on the sign. Okay? Which quadrants will the tangent of 45 be positive? Quadrant 1 and quadrant 3. Okay, right? Yeah. This is actually true for all tangents, right? In quadrant 1, the x is positive and the y is positive. So every time you calculate a tangent of anything here, a positive divided by a positive will be positive. Why is quadrant 3 also going to produce a positive tangent value? Here. Good. Every point down here is going to have a negative x coordinate and a negative y coordinate, so the negative divided by the negative will be a positive. What about tangent values in quadrant 2 and quadrant 4? Good. In each of those quadrants, either the x or the y value, only one of them is negative. It doesn't really matter whether our negative's in the numerator of our fraction or the denominator. In the end, that means we're just getting a negative value. Okay? All right. So anything with 45s is going to turn out to be 1. I kind of have that one memorized because it's easy and we do the same, and I get that idea. All right. 30s and 60s. I'll be perfectly honest with you. I know that these two numbers come up, but I always forget which one is which. But I immediately know when I think about this setup, okay? Because look for 30. If we're doing 1/2 divided by root 3 over 2, I know that that radical is going to end up in the denominator, so I don't do all the work every time. I just go, oh, that's the one that's root 3 over 3, okay? Whereas when I do the 60, because it's root 3 over 2 divided by 1/2, the radical stays in the numerator, I know that's the one that's rad 3. The only reason I have rad 3 and rad 3 over 3 memorized is not really because I tried to memorize that those are the tangents, because I don't really mind doing the work, but more because, I do this every year, and so these numbers start to come up, right? And then you'll recognize them. You guys are going to do a lot of problems, too, so whether you want to memorize those numbers or not, they might just start coming up. I was talking to someone about the homework they did, over the weekend, and even before we were doing the unit circle, the problems you guys were doing where they gave you an angle and said, find the sine of the angle, or the same types of numbers kept coming up because they only gave you 45, 45, 90 triangles or 30, 60, 90 triangles. And those numbers that were coming up were numbers that we're familiar with our unit circle. So you have a choice. You can memorize that every 30-degree reference angle is going to have a tangent of root 3 over 3, and every 60-degree reference angle is going to have a tangent of rad 3. Okay? Or you can do the work every time, or you can get familiar with these numbers and kind of set up the work and be like, oh, yeah, now I know the answer. Okay? You just got to be at a place where you could at least, if all else fails, you should be able to take the y-coordinate, divide it by the x-coordinate, and figure out the tangent. Okay? Is this all right with everybody? Yes? Okay. How many people are like, I'm memorizing? Easy peasy. Got it. Good. How many people are like, forget that, I'm just figuring it out every time? And how many people are like, I don't know what you're even talking about? Anybody? Okay. Good. Nice. Okay. All right. Next thing, reciprocals. Okay? I'm just going to write some random problems up here that I want you to be able to solve. Now, eventually, this would be like what your non-calculator part of the test would look like. It would have questions like, what's the sine of 30? What's the cosine of negative 270? Now, I know we didn't do negative 270, but you should be able to figure out where that is and say, oh, that's the same as positive 90, and then answer the question. So basically, this plate needs to be like a picture in your head that exists there at all times, and you can figure these things out, okay? So you'll probably be like at the test, probably wanting to draw some things out, at least maybe first quadrant stuff. That's usually what students like to do. I give them the test, they want to write some things down real quick, that they know. Totally up to you. We all have different levels of, how much we memorize and how much we have to figure out. So let's do a couple of problems. Let's find the cosecant of 240. Let's find the secant of, it's not pretty, 5 over 6. Cotangent negative. Made the angles harder to figure out too, just to make your life a little bit extra difficult. Just to give you an idea of what we're trying to do. So I want you right now to try and figure out these 3 problems, keeping in mind that you totally have your circle your plate as a reference right now for your unit circle, but that if these are 3 very fair non-calculator test problems, okay, that as soon as you are familiar with the unit circle, whether you jot some things down or you just see it all in your head or whatever the case may be, you could answer these 3 questions strictly on your own knowledge with no assistance. Okay, so what I'm going to do over here, before I write my final answer over there, how I'm figuring this out, because I don't really know how else to show you the work, because a lot of it is internal. But so, cosecant of 240, the first thing I'm going to think about is what is the sine of 240. Then either I am so stellar at memorization that I'm like 240, that's a 60, and then I spit out whatever else it is, whatever, and I have it on my mind. Or if it takes you a little more than that, sometimes I have to process a little further and be like 240. Oh yeah, of course. 240 is like down here. It's like a 60. The minute I know that, then it hits me. Okay, root 3 over 2 and 1/2. and it's going to be 1/2 root 3 over 2 because it's a 60, which is a longer down. So then I know, like, okay, it's 1/2 root 3 over 2, and I know that they're both negative, and then I know that the sign is the y coordinate, so that's this one. Okay? So that's what my brain goes through at different speeds depending on how long it's been since I did trig and stuff like this, right? But that's generally what my brain goes through each time. Okay? So I have what the sine of 240 is. The next thing I'm going to do is I'm going to get the cosecant. So to get the cosecant, I basically take the reciprocal. Issue with leaving this as our final answer is what? Yeah, so we need to rationalize the denominator. So I'm getting negative 2 rad 3 over 3. Okay. Is that okay to clarify the thought process and then how I get the actual answer? No. Thank you. All right, so secant of 5 pi over 6. Somebody tell me, what's the first thing we're going to think about? Okay, so 30 degrees and cosine. So I hear both of you. So this is really a cosine problem and then a reciprocal. And then because you saw the 6 in the denominator, we're thinking it's a 30 degrees. So that's good to know right away. And then to know which quadrant it is, we're going to have to know like the negative, positive, right? Well, I know that pi is 6 pi over 6, so the 5 pi over 6 I know is like in that one right there. Okay? And that tells me negative x coordinate, positive y coordinate. And because it's a 30, it's a long x and a short y. So root 3 over 2 for x and 1/2 for y. Okay. All right, so then since it's cosine, I would be concentrating on the x coordinate, which in this case is negative root 3 over 2. And then the reciprocal of that. Oh, it's so strange that they ended up being the same. Is it really that strange? No. The cosine of a 30 is the same thing as the sine of a 60. So you're going to see a lot of these number interactions where the similar numbers are coming up, right? So we already did the rationalization right there. Okay. Any questions about that one? All right. Cotangent of negative 11 pi over 6. So Matt was asking a question that I think is valid for all you guys to know. So with tangent, since, well, if you haven't memorized, you're just going to take what you have memorized and then you're going to take the reciprocal. If you're a person who's dividing it out to get the tangent, it might be easier, instead of finding the tangent and then flipping it over, to just from your original division, think about dividing it the other way. So he was pointing out, like, you could just do x divided by y. You don't have to find the tangent first and then flip it over. But either way is fine. Okay? All right, so cotangent of negative 11 pi over 6. I don't know. So if you are thinking this way, you'll find the tangent first. Okay, what kind of angle is this? Negative 11 pi over 6. 30. Okay? And which quadrant am I ending up in? 1. Okay, so like fourth, but in the negative direction. So we end up in 1. Because it's negative 11 pi over 6, we're going that way, right? So we end up right here, because I know 11 pi over 6 is right before 12 pi over 6, which is 2 pi. So I'm trying to use these, like, things I can grasp onto in fraction world, that like 6 pi over 6 is the same as pi, and 12 pi over 6 is the same as 2 pi, to help position myself quickly without having to, like, count or convert. If worst came to worst, could I convert this to degrees and then work from there? Yeah, this is going to take me a little bit longer. Okay? All right, so I know I'm over here. Again, I know it's a 30 because of the 6 in the denominator. So then I know the coordinates here are positive, and because it's a 30, that's a longer x, so root 3 over 2, the shorter y, so 1/2. Okay? So two choices here. I either find the tangent, okay, by doing the y divided by x, or I go straight to finding the cotangent by doing what? X over y, right? Like flip it over. So you can either find the whole tangent thing first and flip it at the end, or you can flip what you're dividing right at the beginning. Okay? So if I wanted to find cotangent, I could say, okay, I'm going to do x divided by y this time, because it's cotangent and not tangent. So x divided by y. And then I already know, like, oh, I know how this is going to work out because I have like this root 3 over 3 and root 3 mentality going on. And so I know this is going to be one of those two things. And when I see the radical in the numerator right here, I know what it's going to be. But if I didn't know, then I just write it out. Then I see that the 2's would cancel. And I get rad 3. Okay? So are we okay with the process we have to go through? So the most basic level of knowledge is knowing your unit circle so you can answer straightforward questions like, what is the sine of 60? What is the cosine of 30? What is the sine of 225? What is the tangent of this? Stuff like that. Beyond that is being able to answer things like reciprocals and stuff like that where you have to think about those things and then expand on them a little bit. Okay? Now, we have a quiz on Friday. Okay? On Friday, I will ask you some questions. I'm not going to let you use your plate on the quiz. Okay? So on Friday, there are going to be questions covered on stuff since we've come back from spring break. So that involves things like, can you list for me coterminal angles with this? Okay? Or which quadrant is this angle in? Can you find the tangent of 300 degrees? So stuff on the plate, but remember we also did a couple things before that, like converting and finding coterminal angles and positions of angles and degrees and radians and stuff like that. Now that you've done that stuff is kind of like piece of cake because you've been using it all the whole time. So this will probably be the hardest thing. So your goal over the next 2 days, which I tried to tell you on Monday, that as we were doing it, you should internalize the patterns that we're seeing, and that's why we did it slower and color-coded and all this stuff. But hopefully then, memorizing this is not like, oh my gosh, you expect me to know that many pieces of information in like a day? No. Okay? I've already given you 2 days. And we really know if we really learn what's going on in the first quadrant, we can just expand that to everything else in the circle. And so the goal is to make those connections and build those patterns. Okay? So your quiz will be a non-calculator quiz. Because even if you're converting from degrees to radians, the most work you have to do there is kind of like cross-canceling or reducing fractions, and I think you can do that without a calculator. Okay, I know your calculator helps you, but I think you can do it without, okay? And I want to be able to ask you questions like this and get an answer from you from what you really know as knowledge, not what your calculator is telling you. Okay? Does this make sense? Yes? All right, and then we're only learning one other thing in this entire unit, okay? And then our test is going to be next week. Okay? One other thing. And I'll give you a heads up of what that one other thing is. It would be like this. If the sine of the angle is 1/2, which angle am I talking about? Any answers to that question? If you know the sine of the angle is 1/2, 30 degrees. There's actually another one on there. 150. And then you could actually say like, 390. You could keep adding the 360 to them. So there's technically infinitely many answers, but mathematicians have said, wait a minute, I want to ask that question and us all to get the same answer. So there are some restrictions on which one we pick, and we would pick the 30-degree angle. So you know how on your calculator you used to do like inverse sine of like 1/2 or something, and it would tell you what the angle was? We're basically going to do that in our head by knowing our unit circle and knowing the sines and cosines, the x and y coordinates. If someone says, what's the inverse cosine of root 3 over 2? Okay, that means what's the angle that has a cosine of root 3 over 2? You're going to say 30 degrees. Okay, so knowing your unit circle right now is going to help you with that last lesson that we have to learn too, and then we'll test, like I said, next week. That's all we have to learn, but you're going to need some time to learn notation of the inverse part of it, and you're going to need some time to like process that and be able to figure it out. Okay. All right, so you guys can start. I'm going to post